So let's let a and b be complex numbers such that a plus 1 times b plus 1 is equal to 2, and a squared plus 1 times b squared plus 1 is equal to 32. So find all possible values of a to the 4 plus 1 times b to the 4 plus 1. Now to start, let's multiply the first equation out. So we get ab plus b plus 1 is equal to 2. And so moving the 1 and the ab over to this side will then give us a plus b is equal to 1 minus ab. And now squaring both sides gives us a plus b squared is equal to 1 minus ab squared. Now, a plus b squared is equal to a squared plus 2ab plus b squared. So moving the 2ab to this side gives us a squared plus b squared is equal to 1 minus ab squared minus 2ab. And now expanding the 1 minus ab squared then gives us that a squared plus b squared is equal to 1 minus 2ab plus a squared b squared minus 2ab. Now rearranging terms then finally gives us a squared plus b squared is equal to a squared b squared minus 4ab plus 1. Okay, so now looking at the second equation, we then have a squared b squared plus a squared plus b squared plus 1 is equal to 32. Now a squared plus b squared is equal to a squared b squared minus 4ab plus 1. And so we get a squared b squared plus a squared b squared minus 4ab plus 1 is equal to 32. Alright, so now I'm actually looking to solve for the value of ab here. So I'm actually going to turn this into ab all squared. So now combining like terms and moving everything over to the side will then give us 2 times ab all squared minus 4ab minus 30 is equal to 0. Now dividing everything by 2 will finally give us that ab all squared minus 2ab minus 15 is equal to 0. Now we can factor this as ab plus 3 times ab minus 5 is equal to 0. And so ab is equal to negative 3 or positive 5. Alright, so now with these two in mind, let's move this to the top. So now we can substitute negative 3 or 5 into the second equation here. So substituting negative 3 will give us 9 plus 12 plus 1, which is also equal to 22, or 25 minus 20 plus 1, which is equal to 6. So if ab is equal to negative 3, then a squared plus b squared is equal to 22. If ab is equal to 5, then a squared plus b squared is equal to 6. So now finally, let's find all possible values of a to the 4 plus 1 times b to the 4 plus 1. So a to the 4 plus 1 times b to the 4 plus 1 is equal to a to the 4 times b to the 4 plus a to the 4 plus b to the 4 plus 1. So this is obviously equal to ab to the power of 4. So we have ab to the power of 4. But then let's try to turn this in terms of a squared plus b squared and ab. So let's try writing a squared plus b squared all squared minus 2a squared b squared plus 1. And finally, we can write this as ab to the power of 4 plus a squared plus b squared squared minus 2 times ab all squared plus 1. So first, let's consider the case if ab is equal to negative 3 and a squared plus b squared is equal to positive 22. So this is then equal to 81 plus 484 minus 18 plus 1. So now adding these terms together will then give us 548. So let's move this over as our first solution. So we have 548. Now second, we have 5 to the power of 4 plus 6 squared minus 2 times 25 plus 1, which is then equal to 625 plus 36 minus 50 plus 1. Now summing all these terms up will then give us 612, and that is our second answer. And so our final solutions are 548 and 612, and so we are done. Alright, thanks for watching, hopefully you enjoyed, and hopefully I'll see you next time.